Okay, adding and subtracting radical expressions. What I mean by radical expressions is anything underneath a root sign. Could be your square root, your cubed root, fourth root, fifth root, sixth root, any root. This is what we're talking about, your radical expressions. It's important to note that when adding and subtracting radical expressions, that the root, the number, whether it's square root, cubed root, fourth, fifth root, has to be the same, okay? It has to be the same root. And what's underneath the radical sign, what we call the radicand, has to be the same as well. Then what you do is you add, basically adding what's out in front, A and B. So in other words, this problem here, if I have 3 root 6 minus 4 root 6, I could subtract these because they're both square root and the sixth is similar underneath both cases. So I could turn this into 3 minus 4 times root 6, or I could say that's negative 1 root 6. Okay, so this is kind of the rule for how these are going to work. And I want you to note that this is the rule that if you're trying to do this, this is breaking the rules. So if you have, for example, square root of 4 plus square root of 9, and you're going to say, okay, that's the square root of 4 plus 9. Okay, that you can't do this. And here's why. Square root of 4, that's 2. Square root of 9 is 3. So you're saying that equals square root of 4 plus 9 is 13. So you're saying 5 equals the square root of 13. Okay, so you can't do this. Okay, if you see this type of activity going on where you think you're just going to add them underneath one radical sign, that's wrong. Okay, here's the rule for what you need to be doing. So we're going to go through a couple practice problems. These are fairly simple. And you're going to start to catch on how these radical expressions, adding and subtracting them, how they work. Okay, just keep in mind this is the rule. You could write this down. Is what I suggest doing, is writing it down so you have it available. We already did the first problem. Let's go over the second one here. So we notice that the root is the same. So we have square root. Okay, that's the same. So that's the first check that we need to check, that once again, these roots, the nth root has to be the same. And we also see that what's underneath the radical sign is the same. So we know we could actually do this. We could do this operation. So we're going to say negative 3 plus 4 times root 7. So that's 1 times root 7, or just root 7. Okay, negative 11 times root 21 minus 11 times root 21. So we see that this one follows our rules. So we could say negative 11 minus 11 times root 21. We say that's negative 22 times root 21. Okay, there's our answer. Okay, negative 9 times root 15 plus 10 times root 15. So we could go ahead and say this is negative 9 plus 10 times root 15. It equals 1 times root 15, or just root 15. Okay, negative 10 times root 7 plus 12 times root 7. Okay, we see this goes along with our rules, so we're going to go ahead and say negative 10 plus 12, parentheses, times root 7. Okay, negative 10 plus 12, that gives us a positive 2, root 7. Okay, negative 3 times root 17 minus 4 times root 17. So we're going to say negative 3 minus 4 times root 17. Negative 3 minus 4 gives us negative 7. Root 17 is our answer. Okay, negative 10 root 11 minus 11 times root 11. So once again, we notice this is the same root, and we have the same number underneath the radical sign. So we could say this is negative 10 minus 11 times root 11. So that's going to be negative 21 root 11. Okay, before we get into this next one, I kind of want to point something out, is that if you have the square root of a times b, they're being multiplied, that this equals the square root of a times the square root of b. Okay, that also means that the square root of a times the square root of b equals the square root of a times b. Okay, you're allowed to do this when you're doing multiplication. If you're doing addition, square root of a plus the square root of b, that you can't add them underneath one sign. Okay, if you're doing addition, you can't put them underneath one radical sign. If you're doing multiplication, then you're allowed to do it. So it only works for multiplication. It does not work when you're doing addition. Okay, so we're going to kind of use this idea for the next set of problems that we have here. So keep this rule in mind. You could write it down. I'm going to go ahead and move it kind of out of the way here. Just keep this rule in mind. So here's what we're going to do. Here we're going to say that this equals negative 2 times root 3 plus 3 times 27 is 3 times 9. Okay, so that means this entire thing is negative 2 times root 3 plus 3 times root 3 times root 9. Okay, here it is. We just did our rule. Here's your A, here's your B. A and B, I just kind of separated them out. Okay, so now we have negative 2 times root 3 plus 3 times root 3 times square root of 9 is 3. Okay, so this equals negative 2 times root 3 plus 9 times root 3. Just multiplying the 3's together, 3 times 3. Remember, this is all being multiplied together. A times B times C. Okay, I could also say that that's A times C times B. Okay, so just moving things around. So now we could go ahead and finish this. We could say that this equals negative 2 plus 9 times root 3. Negative 2 plus 9, that's going to give us a positive 7 root 3. There's our answer, 7 times root 3. Okay, 2 times root 6 minus 2 times root 24. Okay, so we're going to go ahead and say that this equals 2 times root 6 minus 2 times root 24. We're going to say that that is 4 times 6. So now we could say that this is 2 root 6 minus 2 times root 4 times root 6. Okay, so that equals 2 times root 6 minus 2 times, well, square root of 4 is 2 times root 6. So we're going to say this is equals 2 times root 6 minus 4 times root 6. Okay, so that equals 2 minus 4 times root 6. I'm going to say that this equals negative 2 times root 6. There's our answer, negative 2 times root 6. Once again, all we're doing is our rule here. Okay, just like we did on the last problem. Okay, 2 times root 6 plus 3 times root 54. So we're going to say that this equals 2 times root 6 plus 3 times 54. We're going to say that that is 9 times 6. So now we have 2 times root 6 plus 3 times root 9 times root 6. Okay, once again, using our rule, A and B. Okay, here's A, here's your B. So now we're going to say that this is 2 times root 6 plus 3 times root 9 is 3 times root 6. This equals 2 times root 6 plus 9 times root 6. So we're going to go ahead and say that this equals 2 plus 9 times root 6 equals 11 times root 6. There's our answer, 11 times root 6. Okay, negative 1 times root 12 plus 3 times root 3. Remember, once again, if you don't see a number in front of something, you're going to automatically know that that's a negative 1. Okay, a negative sign means negative 1. You don't see a number out there, there's a 1. There's an invisible 1. I'll draw that 1 in for you. There you go. So, negative 1 times root 12 plus 3 times root 3. Okay, we're going to go ahead and say that that equals negative root 4 times root 3 plus 3 times root 3. Okay, so that equals negative 1 times square root of 4, that's 2, times square root of 3 plus 3 times square root of 3. So we get negative 2 root 3 plus 3 times root 3. So that equals negative 2 plus 3 times root 3. Negative 2 plus 3 is 1. So we have 1 times the square root of 3, or just square root of 3. Remember, you don't have to show the number 1. When you're doing your math, you usually don't have to show this 1. You know, there's a 1, an invisible 1 here. See, there's also an invisible 1 here. I just didn't include it. So, yeah, once again, just using our rule, square root of a times b equals square root of a times square root of b. Okay, 3 times the square root of 3 minus square root of 27. So we're going to go ahead and say that this equals 3 times the square root of 3 minus square root. 27 is 9 times 3. So we're going to say that this equals 3 times the square root of 3 minus square root of 9 times square root of 3. Okay, that equals 3 times square root of 3 minus square root of 9 is 3 square root of 3. So 3 square root of 3 minus 3 square root of 3. Okay, 3 minus 3 times square root of 3. That equals 0 times square root of 3. Okay, anything times 0 equals 0. Okay, anything times 0 equals 0. So this kind of cancels itself out. What we're left with is 0. So our answer for this problem is 0. Okay, 3 times square root of 8 plus 3 times square root of 2. So we're going to say that this equals 3 times square root of 4 times 2 plus 3 times root 2. So this equals 3 times square root of 4 times square root of 2 plus 3 times square root of 2. Okay, so that equals 3 times 2 times square root of 2 plus 3 times square root of 2. So this equals 6 square root of 2 plus 3 square root of 2. So this equals 6 plus 3 square root of 2. So this equals 9 root 2. Okay, there's our answer, 9 times root 2. Okay, negative 3 root 6 plus 3 root 6. Okay, we see that the indexes are the same and the radicand, or what's underneath the radical sign, is the same. So we know we could do our first rule, negative 3 plus 3 times root 6. Once again, this is a 0 times root 6. Anything times 0 is 0, kind of cancels itself out, or self-canceling, so we're going to say that the answer is 0. Okay, that's our answer. Once again, the answer is 0. Okay, negative 3 times root 20 minus square root of 5. So we're going to say that this equals negative 3 times square root of 4 times 5 minus square root of 5. That this equals negative 3 times square root of 4 times square root of 5 minus square root of 5. Okay, remember, once again, we're just doing our rule here. We're just splitting it apart, just like we did here. Okay, so that means that this equals Negative 3 times square root of 4 is 2 times square root of 5 minus square root of 5. So that means that this equals negative 3 times 2. That gives us negative 6 times root 5 minus root 5. So that equals negative 6 minus 1 times root 5. Once again, we don't see a number out in front. That means 1. There's an invisible 1 here. So negative 6 minus 1 gives us negative 7 root 5. Okay, there's our answer. Negative 7 times root 5. Two times root 45 minus 2 times root 5. We're going to say that this equals 2 times root 45. We're going to say is 9 times 5 minus 2 root 5. So this equals 2 times root 9 times root 5 minus 2 times root 5. Okay, that equals 2 times 3 times root 5 minus 2 times root 5. This equals 6 root 5 minus 2 root 5. So we're going to say that this equals 6 minus 2 times root 5, which equals 4 times root 5. There's our answer, 4 times root 5. Okay, 3 times root 18 minus 2 times root 2. We're going to say that this equals 3 times 18. We're going to say is 9 times 2 minus 2 root 2. So this equals 3 times root 9 times root 2 minus 2 times root 2. So this equals 3 times root 2 minus 2 times root 2. That's going to equal 9 times root 2 minus 2 times root 2. I'm going to say that equals 9 minus 2 times root 2, or 7 root 2. Okay, there's our answer, 7 root 2. Okay, negative 3 root 18 plus 3 root 8 minus root 24. So let's break this one up. Let's say negative 3 times 18. We're going to say that's 9 times 2 plus 3. 8 is 4 times 2. Minus 24, we're going to say that's 4 times 6. Okay, so that means we have negative 3 times root 9 times root 2 plus 3 times root 4 times root 2 minus root 4 times root 6. Okay, so that equals negative 3 times root 2 plus 3 times 2 times root 2 minus 2 times root 6. Okay, we're simply taking the squares of what we can, so square root of 9 turns into the 3. Okay, the square root of 4 turns into the 2, and this square root of 4 turns into this 2. Okay, same exact thing we've been doing. So now we're going to say negative 3 times 3, that's negative 9 times root 2, plus 3 times 2, that's 6 times root 2, and minus 2 times root 6. Now, we could combine these two terms because same root, square root, and the same radicand 2 is similar. But we can't combine this one. Why? Because the radicand is different. Okay, so this is square root of 6. Okay, that's different from square root of 2. Okay, so this one we're just going to kind of leave it alone. So we're going to say that this equals negative 9 plus 6 times root 2 minus 2 times root 6. Negative 9 plus 6 is negative 3 root 2 minus 2 root 6. And there's our answer. Negative 3 times root 2 minus 2 times root 6. Okay, so let's just get into this. We're going to say 3 times 18, we're going to say is, again, 9 times 2, plus 3, 4, or 12, we're going to say is 4 times 3, and 2 times 27, we're going to say is 9 times 3. Okay, so this equals 3 times root 9 times root 2, plus 3 times root 4 times root 3, plus 2 times root 9 times root 3. Okay, so this equals 3 times 3 times root 2, plus 3 times 2 times root 3, plus 2 times 3 times root 3. Okay, so that equals 9 times root 2, plus 6 times root 3, plus 6 times root 3. Okay, once again, we could only combine these two terms. Okay, this term we're going to leave alone because the 2 is different from the 3's. So we're going to say this equals 9 times root 2 plus 6 plus 6 times root 3. It equals 9 times root 2 plus 12 root 3. Okay, there's our answer. Okay, negative 3 root 5 minus root 6 minus root 5. Okay, it doesn't look like we could break anything apart underneath these signs. Looks like they're kind of already factored out. You know, I could change the 6 into a 2 times 3, but I won't be able to pull anything out. So we're going to go ahead and combine this term and the last term. So what we could do is we could kind of move things around. So we could say this is negative 3 times square root of 5 minus square root of 5 minus square root of 6. Okay, that's called the commutative law of addition, which basically means if I have A plus B plus C, I could change the order around any way I want. I could say that this equals A plus C plus B, or I could say that this equals C plus B plus A. And the reason for this is if I have like 9 plus 3 plus 5, that's the same as 3 plus 5 plus 9. Okay, I could kind of switch the order around any way that I want, even if it has a negative sign. So that's your commutative law of addition, is if you have things that are being added or subtracted, you could kind of move their position in relative order from left to right. You can move their position. So that's what I did with this negative root 6 and this negative root 5. I just switched the position or the order. Okay, you could do this. This is your commutative law of addition. So we're going to go ahead and say that this equals negative 3 minus 1 times root 5 minus root 6. Or this equals negative 3 minus 1, that's negative 4 root 5 minus root 6. Okay, there's our answer, is negative 4 times root 5 minus root 6. Okay, negative 3 root 2 plus 3 root 20 minus 3 root 8. Okay, we're going to say this equals negative 3 times root 2 plus 3 times 20. We're going to say is 4 times 5 minus 3, 8. We're going to say is 4 times 2. So that gives us negative 3 root 2 plus 3 times root 4 times root 5 minus 3 times root 4 times root 2. This equals negative 3 root 2 plus 3 times 2 times root 5 minus 3 times 2 times root 2. This equals negative 3 times root 2 plus 6 times root 5 minus 6 times root 2. Okay, once again, we're going to use our commutative law of addition. So we're going to say this equals negative 3 times root 2 minus 6 times root 2 plus 6 times root 5. Remember our commutative law of addition, we're just moving this term, okay, including the negative sign, this term, and this term, we're simply switching places. Okay, that negative sign has to go along for the ride. This is your commutative law of addition, moving these back and forth. So now we have negative 3 root 2 minus 6 root 2 plus 6 root 5. We're going to go ahead and say that this equals negative 3 minus 6 times root 2 plus 6 times root 5. Negative 3 minus 6 is negative 9. Root 2 plus 6 root 5. Okay, here's our answer. Okay, negative 3 root 3 minus root 8 minus 3 root 3. We're going to say this equals negative 3 times root 3 minus square root 8. We're going to say is 4 times 2 minus 3 root 3. So now we have negative 3 root 3 minus square root of 4 times square root of 2 minus 3 root 3. That equals negative 3 times root 3 minus 2 times root 2 minus 3 times root 3. Okay, once again, our commutative law of addition, we could kind of move this term and this term relative in position from left to right. So we're going to say this equals negative 3 times root 3 minus 3 root 3 minus 2 root 2. Okay, now that these two terms have the same root and the same number underneath the radical sign, we could combine them. So we're going to say negative 3 minus 3 times root 3 minus 2 times root 2. So negative 3 minus 3, that gives us negative 6 root 3 minus 2 root 2. Here is our answer. Okay, you made it to the end of the video. I want to thank you all for watching. If you liked this video, please press the like button. Leave a comment down below. Let me know how I'm doing. And subscribe for more videos if you want to see more of these type of math problems, quick mental math tricks, and basic algebra advice. And once again, I just want to thank you all for watching.